Hello everyone, this is Haricharan, and today we'll have the video tutorial for Codeforces round 860, and that's a Division 2 contest. So in this contest I was able to solve problems A, B, C and D, and just to talk about the general problems, I felt that actually problems problem A was like very easy, problem B was a bit harder, and I felt that D was actually easier than C, and you can even see that the number of solves that D has actually more solves than C. So without any delay, we'll begin with the solution. So if I look at problem A over here, you can pause and read the question. So my solution was just a simple greedy algorithm. I thought it was a very easy question. So my algorithm was, if AI is greater than BI, just swap them. So in this case 9 is greater than 6, so just swap them. So if you do that, essentially what you will achieve is that you will be putting all of the bigger elements in one array and all of the smaller elements in other array, and then you just do your check, and after you do your check, if there is no valid solution, then that means it's not correct. So based on this, I'll just like demonstrate this to you also. So if you have these 4 elements, whenever AI is bigger than BI, then you basically just swap them, and finally at the end of all the swaps, you do the check that like AN is greater than all of A1 up to AN, and BN is greater than B1 up to BN. So for example, if you have this particular array here actually A1 is greater than B1, so just swap them. So the first array will become 99, 99, and the second array becomes 100, 100, and that array, this condition is satisfied, so you'll be outputting S here. So the basic idea of the algorithm is to push all of the bigger elements to one array, that is the array B, and all of the smaller elements to another array, that's the array A. So that's my solution here. So I'm just like taking this n here. This Vi is my macro for vector. Also rep is a for loop here. So I'm just basically inputting all of them over here, and whenever A is greater than BA, I'm just swapping them over here, and you can see that I have this for loop here. That's the final check I'm doing. So if for any index A is greater than AN minus 1, that means this condition will not be satisfied. So that means we have a problem, and I'll just output no here. Or even if BA is greater than BN minus 1, that means this condition will not be satisfied. So I'll be outputting no. And if it doesn't fail for any of these cases, then I'll be outputting S here. So I hope that's fine. So let's have a look at the next problem. 3 sevens. So you can pause and read the question. So in this question, there are basically m days here, and in each of the m days there are n different people. So let's start with that here. So the algorithm for this I felt was actually pretty easy. So you start with the last day. Now that's actually the only difficult part in this algorithm, that you actually start with the last day. So if you start from front, it actually won't work, but instead you have to start from back here. So based on that, let's begin with the solution. So basically I have this array. In the first day there were 4 people and their numbers were 1 to 4a. In the second day there were 3 people and their numbers were 2, 9 and 1. And in the third day there were 2 people and their numbers were 1 and 4. Right? So like based on this, what we can do is that actually we'll be starting from reverse, right? We'll be starting from reverse, and we'll be checking. Actually, we'll keep track of a set. I'll call this set to be done. So this done will be some set, and whenever some like some number has occurred in a future day, then I'll actually basically just throw that in here. So for instance, if you look at day 3. Like at the end of so I'll add it from reverse, as I told you. I'll start over here. Now 1, without loss of generality, we can just see that will be the answer for this particular day, and I can do that because there are no more days. I can just choose whatever element I want just arbitrarily. So the answer for the third day, let's say it's 1, and in that array I just throw 1 and 4. Now if you look at the second day, the answer can be 2. That's completely fine. The answer can be 9 also, even that's fine. But the answer can't be 1. Why can't it be 1? Because if the answer was 1, then they can't have participated in day 3. Because of that, the answer cannot be 1. And let's say without loss of generality, the answer was 2. Okay. Now to this set called done, and let's say insert more elements, I'll insert 2 and 9 also to this, right? So if you look at the first day again, now here you can see that 1 is in the set, so that can't be an answer. 2 is also in the set, that can't be an answer. And 4 is also in the set, so that can't be an answer. So the answer has to be 8 over here. So that's our final answer, 8, 2 and 1, or it can be even 8, 9 and 1 or 8, 9, 4 also. Any of the possibilities are fine. Now based on this, actually when will it be minus 1 here? As in, if you look at this, there is even this minus 1 possibility here. When will it be minus 1? Actually it will be minus 1 if you have something like this. Let's say you have something like so let's quickly think of a test case here. So let's say you have 3 days. Let's say in the first day you have 3 people and their numbers are let's say 1, 2 and 3. The second day you have 2 people and their numbers are 1 and 2. And the third day you have 2 more people, their numbers are 1 and 3, right? So if you have something like this, in this case, at the first day, the value of the set done, actually what will that be equal to? If you think about this, done will just be equal to like 1, 2, 3. Now, all the elements in this particular day, right? All of them are actually present in the set done already. So that means none of them are correct. And because of that, we'll be outputting minus 1. So if all the elements in a particular day, if all of them are present in the set already, that means there can't be any correct answer. So we're just outputting minus 1. So we'll have a look at this code here. So if you look at the code, I'm basically just taking in this M as input. I'm keeping track of a vector of vectors here. So VA is my macro for vector of integers. So I have a vector of vectors called A of M. And also I'm just doing this thing here in which I'm just basically inputting all of them here. All this is the input code. Now I have this vector called answer. The answer contains M elements for M days, and I basically initialize all of them to be minus 1. I also have the set called done, as I told you. Now I've started my my iteration over here. As I told you, I'm starting with the last day, so I'm starting at M minus 1, and even I'm now looping over all of the elements in the mth day array. So I'm just iterating over AI here. So A will be a vector. I'm iterating over all the elements of AI. So now I'm just checking if done.count of that element is equal to 0. Now if done.count that element is equal to 0, then that means that can be the answer. So I'm just setting answer A equal to that element, and I'm inserting that element to done, right? Also let's cover the minus 1 case here. Now if there is no such index for which this is valid, that is answer I does not become equal to aij for any index, then that means answer I will be unchanged and answer I will be equal to minus 1. In that case, I'll just output minus 1 and I'll return, right? And now I have this final for loop which just basically outputs all of the solutions, and that's it. So I hope that's fine. Now let's have a look at the third question. As I told you, I felt that actually C was a bit harder than D, but anyways, let's have a look at the solution here. You can pause and read the entire question. So I hope that's fine. So let's have a look at what AI is. A is the number of candies of type I available in the store. BI is the cost per candy. DI is the number of candies per pack, and CI is again the cost of one pack basically, and that will be BI times DI obviously. Now if you look at this, one thing you have to notice is that the price tags, they are actually consecutive. So if you have 44244, you have to use 3 price tags here. One price tag like this, one more price tag like this, and one more price tag like this. So that's something to keep in mind. So since we have that kind of constraint over here, and they have given all the AIs and BIs in the question, actually we have to find what is DI and what is CI, right? So based on this, we'll have a look at the solution. So the thing to note here is actually very interesting. So we'll keep track of all the products here. So I'll actually keep track of the product of this. So if I call this A and BA, I'll keep track of A, BA, that is their product, and I'll also keep track of all the BIs here. So yeah, so actually try to store this in my my array over here. If you look at the first day, that will be just 60. If you look at the second day, that will be 12. If you look at the third day, that will be 70. And if you look at the fourth day, that will be 140. Right? Again, as I told you, I'll have all the BIs here. So I mean, all the BIs are just 3, 2, 5, and 7. So I think that's fine. now let's actually calculate the algorithm. So let's take the first day. First day you can just describe using one price tag. That's always true. Now let's see if you can describe these 2 days using one price tag. Actually, when can you do that? Well, you can actually do that in the following case. You can do that whenever the greatest common divisor of 60 and 12. That's actually just equal to 12, right? So we'll just set our price tag equal to $12. So now what's our price tag? Our price tag is equal to $12. And where did this come from? That's actually it's the greatest common divisor of the product of these two things. So now I have a $12 price tag, but if I have this $12 price tag, that means I can describe, I mean that I can basically utilize all of these things here. So in this particular case, what will be the DI values? CI is 12, but what is DI? Actually DI in this case will be 4 and DI in this case will be 6, right? Yeah, because actually like this times this has to give this. That's the basic idea here. Now let's have a look at the third day and let's look at the GCD of all of these things. So what's GCD of 12 and 70? Well, if you look at that, if you want the GCD of I mean like we just want the GCD of basically 12 and 70, right? And if you want the GCD of 12 and 70, you can just say that will be something like 35 times 12, right? I think that should be correct. Now turns out, let's say, can you have, for instance, this maybe 70 times $12 price tag or something like that, right? So that's the next big question we should think about, and the answer is no, because that number will be way too big and that won't be possible here. Actually, why is that not possible? Well, if the GCD of these three elements that is not divisible by the least common multiple of these things, then our answer is no. So whenever the LCM of all the BI that divides the GCD of ABI, I mean A times BI, then we are fine. But otherwise we have problems, and then we have to start our count again. So we'll actually do the break over here. So if you break it up over here, in the next case again, our cost that just be basically $5 here, right? Our cost will just be $5, and based on that you can like keep proceeding. So if you look at my solution, I'll display that to you. So I'm actually initializing my G, that is my GCD variable, that to be equal to 0, because GCD of anything with 0 is 0. I'm also initializing count to be 1, and I'm initializing the least common multiple to be equal to 1. Now I'm iterating over here. I'm just inputting A and B here. I also define my own GCD function, by the way. That's just based on simple I mean it's just simple common algorithm. So based on that, I have this G here. I'm taking G to be the GCD of G and A times B. So it's the GCD, that is the previous GCD, and A times B. So I have that's fine. And then the least common multiple, that will be equal to the previous LCM. So that will be equal to like the LCM in the previous case times B by GCD. Actually, why is that? Because there's no like neat formula for calculating the least common multiple. You have to do prime factorization or something like that. You can use the fact that LCM of any numbers x and y, that is actually equal to x times y divided by the GCD. So this is actually a very nice fact that you can utilize. Yeah, so that's what I've done here. So this actually calculates their least common multiple. Now, if this LCM divides G, then I'm fine, no issues. If not, I'm actually incrementing my count, and I'm setting G to be equal to A times B, and I'm setting LCM to be equal to B. So I hope that's fine, and in the end I'm actually outputting this count. So I hope that's fine. Now let's have a look at problem D also. So if you have a look at problem D, the basic, I mean you can pause and read the question if you want. Now what is the basic idea? Well, you can just use a simple greedy algorithm in this case. So basically, let's have a look at this max of all of this minus the minimum of all of this. So So what will that be in this particular case, right? So this is my given test case. So let's have a look at what that particular quantity might be. Well, if you think about this, the max of all the numbers minus the minimum of all the numbers, in this particular case that will just be equal to 9, right? And let's keep that in our mind. Now in my greedy algorithm, I'll do the following thing. So I'll start with the most negative number. So what is the most negative number? That's actually -5, right? I'll start with -5. Now I'll greedily try to add another negative number and see if it causes problems. Now if I add -2 and we look at the value of the prefix sum, there is a sum up to that point, that sum will actually be equal to -7. Now since the absolute value of -7 is smaller than 9, I have no problems. So inserting -2 is fine. Now I'll try to add the smallest positive number. So that will be 3 here. So I'll add in 3 here and I add in 4 here. And that's it for like the first part. So for second part, if you have this particular example, this might make it a bit clearer. So if you have this particular case here, what will my algorithm do? Here in this case, the value of maximum of all the elements minus the minimum of all the elements is equal to 5 actually. Now since that is equal to 5, I'll do the following thing. So I'll start with the like most negative number, that is -3. Now can I insert one more -3 here next to it? And the answer is no, right? Actually that won't be valid, because then our sum will be -6 and that will cause problems. So instead I'll add a 2 here. Now again my prefix sum is -1. Now I'll greedily try to insert -3 here. Now can I put -3? And the answer is yes. I can put -3 without any problems. So I just put -3 here without any issues. That's fine. Now I just put the remaining positive elements. So I hope that's fine. So if you look at this test case again, actually my algorithm that will yield a solution of -3 1 1 and -3 1 1 1. You can think of why this might be true. Now again I have one more test case here. Again same thing. I have this test case also here. Again we'll quickly go through this test case also. I'll put the most negative number first, as -4. Next, can I put in -4, one more -4? And the answer is no. Actually, why can't I put one more -4? That's actually because if I put one more -4, then my prefix sum will be -8 and that will cause problems. Because actually in this case, the maximum of all the elements minus the minimum of all the elements, that turns out to be 8 here. So I can't have one more. I can't have one more -4 here. That won't be correct. So I just have the smallest positive number of +3 here. Now what should I do? Now can I add a -4 here? And the answer is yes. So I'll just add a -4. That's fine. Now what can I do here? Now I can't add one more -4 here. That won't be valid. So instead I'll add the next smallest positive number, that's 4, and then I'll add the remaining -3 and the +4 here. And you can do the same thing for the last test case also. So I hope that's fine. Now if you look at this, I actually got this runtime error the first time I solved the problem. Now I got this runtime error because of one edge case I was missing. So actually if you have the following case here, that is if you have, let's say, a bunch of zeros. Now if you have a bunch of zeros, the answer will be no always. Actually why is that? Because this right hand side, there is max of all the elements minus min of all the elements, and that will be equal to 0. And the left hand side also will be equal to 0. Because of that, the answer will be no. So this will be the case where the answer is no. But in every other case, the answer is yes. So I was missing this edge case, so that's why I got this this runtime error here. So now let's have a look at the correct code here. So implementation wise, it was pretty easy. So I'm just keeping track of a multi-set of all the positive and the negative integers. I'm also keeping track of the number of zeros. That's because actually where you put a 0 doesn't matter. So even in this case, wherever you put the 0 doesn't matter. I can put it here, or even I can put it here. It doesn't matter at all. Because of that, I'm just keeping track of the number of zeros. Now, if positive size equals 0 and negative size equals 0, that means basically all the elements are 0, right? In that case, I'll just output 0. Now I'll keep track of vector of answers and I'll just add all the zeros initially. I'll just put all the zeros at first, because why not? Next, I'm keeping track of the sum. The sum variable is the prefix sum I told you about. It's a sum of all the elements up to that particular point. And this mx is another thing I told you about. It is the largest positive element minus the most negative element. That is the smallest negative element. So that will be a positive r beginning. Positive r beginning gives you the largest positive element. neg dot begin gives you the smallest element in the entire array. Now, while these sets are not empty, I'm doing the following thing. So I'm checking if neg is empty or not. Now, if neg is empty, that means I have to insert all the positive elements I have. So if neg is empty, it directly inserts all the positive elements. Now, if neg is not empty, and absolute value of sum plus neg dot begin is less than mx. So sum is the sum of all the elements up to that point. That plus neg dot begin. Neg dot begin actually gives you the most negative element. If that plus sum, their absolute value is smaller than mx, that means I can insert that. So I just insert that into my answer array. From neg, I'll actually erase that element, and from sum, I'll be adding that element, right? If this is not possible, I'll do the exact opposite. I'll to sum I'll be adding positive begin, and then to answer I'll be pushing back positive begin, and then I'll do positive erase positive begin. So now in this case the answer will be yes, and I just iterate over the entire array, and I just output the answer. So I hope that's fine. So that was the video tutorial for A, B, C and D problems. So I hope you enjoyed this. Make sure you subscribe to the channel. Thank you. This Harichan from the Programming Club.